get going. This and every previous webinar is recorded. There's well over 100 in our YouTube library. So just go ahead and search for Kaleido Blockchain on YouTube, and you'll see a curated list of overview level, medium level, and then very technical webinars spanning the gamut from key materials to sort of API surface area to, application specific constructs. The objective of this series that we're doing today is, this is the second in the series. We're looking to decompose kind of the broader Hyperledger, Firefly, and Kaleido and Asset Platform stack. So you'll see those three layers logically displayed on this page right here. So we're going to go through things like connectivity across private consortia type chains, all the way into EVM compatible public chains. We're going to talk through the power of that middleware engine called Firefly, how it helps with API generation, how it helps with events, how it helps with key integrations. And then we're going to look at the application accelerator modules on top and the API surface as well for the asset platform. Would love for folks to be interactive today. So if you have a question, just raise your hand or throw it into the chat. I'll do my best to monitor, but have a few colleagues on the call with me that'll hopefully interrupt me if there's anything that comes up. So today we're going to focus on smart contracts. Specifically, we're going to talk about getting your source code into the system via the UI or programmatically. We're going to look at a pattern for upgrading smart contracts and try to understand how a proxy implementation will store the state so that you can change your source logic but still have the state preserved. We're going to look at how to dynamically receive events out of the system. And then we'll look at all things APIs as well. So let's jump right into it. And again, don't be shy if there's any questions. So this will look familiar if folks have joined a webinar in the past, but what we're going to do logically here is we're going to sort of open the door on the smart contracts module, understand how to use some of the Lego blocks that Kaleido provides, but then how to bring in your own bespoke source code as well. So we'll go ahead and start with that, and then I'll take you through the world of upgradable smart contracts. Then we'll start delivering some events, and then we'll look at the API surface. And I think that covers the agenda of what was promised in the invite. So let's go ahead and just jump right in here. A lot of stuff has been happening, and I did a lot of samples and due diligence on the upgradable flow. So you'll notice a lot of things have that nomenclature. So the first thing we can do is we can create a build. So this is bringing source code into the system. And you have a bunch of doors that you can go through when you want to bring your smart contracts into Kaleido, into the asset platform. We'll start with this, the generate a new smart contract using the Lego building blocks that Kaleido gives you. And we see that there's 3 core battle-hardened derived from Open Zeppelin contracts. A fungible 20, non-fungible 721, and then sort of the hybrid, the 1155, where you can do fungible and non-fungible within the same interface. This is typically the starting point for people where you want to, just populate some vanilla source code very easily. I'm going to cheat and probably call this, let's see, just call this Nick actually right here. And we can start populating that source code. So we can make this mintable. We can ask for the code to auto increment the indexes for us. We can make this burnable or pausable. And we need somewhere to, point for our metadata. So we want to do that with URI storage. Ultimately, that'll be an endpoint in IPFS. Now, if you're new to Solidity and you're new to tokens or new to smart contracts in general, I would highly encourage you to visit the Open Zeppelin community. They have a really, really robust library in their Git repository where you can, look through things like basic non-fungible and fungible tokens. You can look at voting patterns. You can look at proxy patterns, upgradable patterns, etc. And if you take a few of these samples in Kaleido, you can hop over to Remix, which is the industry standard IDE for messing around with source code and trying to extend it. And this will let you throw new methods or events inside of here, and it'll, auto compile and lint it for you and let you know where you have vulnerabilities or let you know where it's failing to compile. So a really nice sort of shallow portion of the pool to come into smart contracts and come into Solidity. Ultimately, once you're ready, you're going to bring source code in from some other mechanism. We'll jump back to that here in a second. So let's go ahead and compile this thing first, and then we'll deploy it onto the blockchain. So I'm going to click next. Everything we do in the system, every CRUD operation, anytime we create a resource object, there's a corresponding action for that. So as an administrator or as a developer who likes things cleanly organized and compartmentalized, you can name these actions whatever you want, right? So I could call this, what's the date? 9/12. I'll call this 9/12 build demo right here for my action. And I can park it in an existing folder, or I can create a new folder. So why don't we just park it in ABC right here? So I'm going to create that build, and what's going to happen behind the scenes is the asset platform and Kaleido is going to become our friend right here. It's going to run solc, it's going to run inside of a serverless function, and it's going to go ahead and lint that code and compile that code for us. And once that's done, if that's successful, we can deploy it. And so at this point, I'm going to start looking at the API surface. So you will use this interface for, my guess is, a week, 2 weeks, 3 weeks. But as a developer, especially with complex workflows and a bunch of dynamic, ever-evolving smart contracts, you're ultimately going to automate your surface and write your own cloud jobs. So this turns into kind of the core class that you would use just to push source into the system or to take failed compilations out of the system. You just sort of call this API, point to your code, right? Point to GitHub, point to a local template, push up bytecode and ABIs, et cetera. We'll get into some of those more sophisticated options here in a second. So builds will be that, and then actions is how we start doing stuff with this. So let's hop back here and let's do an action. We did our first action, which was compiling this. Now we want to do our second action, which is deploying this. You can leverage any of the namespaces that you have. We covered this last time, but a namespace is a combination of a blockchain connector and a storage utility. So if we go back to our layer cake right here, a namespace is logically a chain. And then inside of that chain, if it's private, you'll have an IPFS cluster. If you're pointing to a public ecosystem, you'll point to a public IPFS ingress. It doesn't necessarily have to be private. You could have your metadata stored in public IPFS. The common pattern is private, public right there. So again, point to the namespace. We need to provide a wallet. We'll deep dive on wallets in another session, but suffice it to say there are a litany of options with key management and sort of custodied private key delegation in the service right here. The easiest approach is to use what's called a HD wallet. This is essentially a never-ending key tree. It's got over 2 billion keys inside of it. And within those keys, you can create aliases. So you can have very logical, very elegant, practical user naming conventions. I'm going to go ahead and use a KMS-backed key. This is the default key for my namespace right here. Again, I can choose a custom action name right here. So maybe we'll say 9/12 deploy right here. So we can go ahead and deploy that, jump over to the actions, and we can see the life cycle of this. So this will go from pending to succeeded. We're on a private chain here, pointing at Besu under the covers. So these are 5-second block intervals, so that'll happen pretty quickly. And we can see the life cycle of that transaction. We can click on it, we can see the address, we can see who instantiated it. That's my KMS-backed key. And then we can see sort of the work zone or the namespace where that source code was pushed. So pretty straightforward stuff right here. What becomes really interesting is what you can transform your source code into. So that's one thing we definitely want to focus on in today's demo. And we'll go full circle. We've shown this API surface before, but today we're going to actually invoke it, and we're going to create a listener so that we can get dynamic notifications coming out the other end. So think about, any type of blockchain network, especially a multi-party network or a public network for that matter, where you really care about certain smart contract addresses and you really care about certain functions and certain state changes. You need to have your application and your back office dynamically listening and dynamically reacting to those. So we're going to show an example of a webhook where you can get the system, Kaleido, the asset platform, to push you these signatures, these events automatically. And then what you could do is one of two things or both things. You could store the state in a database that sits right next to your application, meaning you don't even have to query the blockchain, or you can start reacting to those events. So you can listen to the signature type, you can listen to the address, you can listen to the signer, etc., and say, go ship this item, right? Once tokens are transferred to me from this account, for example. So let's jump back into this build right here. We'll open this up and we're going to go ahead and create API endpoints. So I just need to point to the specific on-chain address that we just created, which is this. This is sort of why the naming conventions become really critical and really powerful. As you populate your asset platform / Firefly database with a bunch of different CRUD operations, you don't want to get into a guessing game of, oh, I think it was that address and I think it was this namespace, for example. This can be, really, really powerful and really friendly to you if you choose a syntax, choose a convention, and stick to it. We'll see the importance of that in the upgradable flow here in just a moment. So I'm going to select this. It inherits that. So just confirming that. Click next, and then we just need an endpoint name. So I'll stick with the 912 demo syntax. So we're going to create this. Again, jump to the actions. This will happen really fast. And now what we have is a 721 smart contract with functions like, safe mint and approve and burn and transfer. But we'll be able to talk to those in a Web 2 capacity. And we'll be able to sign those with any keys that are inside of our wallet landing zone. And I'll hop back to that in just a second here. So why this is powerful is this removes the need for an Ethereum SDK, which I know a lot of developers have grown comfortable with, but they're still quite esoteric. They're still quite complicated, very low level. And there's a number of APIs that you have to exercise just to do something like an a deployment or an invocation. This is asynchronous fire and forget right here. So for example, if we wanted to mint something, this turns into all of, I think, 4 total lines of JSON right here. You can optionally put an item potency key in there just in case there's a failed transaction or you don't want to submit the actual exact same thing. But this would be all that you need, including another brace right here. So we would just need to provide an Ethereum address, who's going to get this token. Again, remember, we're auto incrementing the indexes, so we don't even have to supply those. And then the URI. So this would be where the metadata is stored. We'll do this in just a second, but wanted to pull that up and sort of show the ease of use right there out of the box. So let's look at some of the other options that are available as well. So we'll go back to our builds, and we can start thinking about other ways to bring source code into the system. Typically, if you have a private GitHub, that will be an acceptable sort of change management system. But if you're running on different emulators or different change repositories, you can create your own cloud jobs, use that API surface against this API surface, and just push your .sol files or push a combination of bytecode and ABI, etc. We'll look at a quick pattern of doing this from GitHub. So this is a contract called Simple Storage. It's not terribly interesting. It has one variable, that's a positive integer, has a function where you can change it, has a function where you can read it, and then it emits an event every time you change it. So all we need to do is just pass in this URL right here. If you were pointing to a private GitHub, this is our public repository, you would obviously include the bearer token. If it's more complex contract, you would supply the name as well. So you can click preview, it'll show the same code that we just saw. Click next, and kind of the same process right here. So I'll call this SS912, and we'll put it in ABC as well again. So same process. This will go a lot faster because it doesn't have any node modules and dependencies to basically import into the system. And again, I'll just pull up the API surface. This ultimately becomes kind of a fully automatable process for you guys. So, 1 week, 2 weeks, 3 weeks, ultimately you'll write your own cloud jobs to do this. So that's the first step on sort of smart contracts 101, how to get them into the system, how to build APIs, and ultimately how to talk to them. I'm going to pivot now, and we're going to look at an upgradable flow. So I have source code out there, and it's got a bunch of balances, for example. Maybe it's a token smart contract. I don't want to deploy a new contract because I want the history of that. And I want to know that I have 1,000 of these tokens or 1,000,000 of these tokens right here. So the pattern for upgradable uses something called a proxy. The proxy understands the address of your logic smart contract, often called an implementation contract, and it stores the state. So as you want to push new source code out into the wild, you just update the proxy, and you teach it about the new address for version 2, version 3, version 4. So we'll go through an example of how that would work. And I'm going to go down here, and I'm going to use this upgrades folder right here. So I have 3 contracts. I have box v1, box v2, and I have the proxy contract. And this uses, give me 1 second. This uses an OpenZeppelin module with a UUPS upgradable smart contract. And the source code's pretty much the same as simple storage. We can take a peek at it down here at the very bottom. So again, just has a positive integer for a store function right here. And then it has a query function called retrieve. The upgraded contract will create a new function called increment. And so what we're going to do in this flow is we're going to deploy the first guy right here. We're going to link him up to the proxy. We're going to invoke this function right here. Then we're going to go ahead and deploy the second guy. We're going to update it to point to this new address. And then we'll just query this guy and prove that it's able to retrieve, the state tree, the storage from the initial contract. Not rocket science, but proves the point. And again, right, via the API surface, once you start understanding this pattern, you can automate everything, and you can even update the API endpoint so your application code doesn't have to change either. Really, really nifty. So let's take this journey through upgrades. So first thing we want to do is go ahead and deploy our first contract right here. So this is box v1. So we're going to deploy this into namespace 2, and we're going to use my KMS wallet. And you'll have to bear with me. I'm going to do some really onerous naming conventions. So we're going to say box v1 deploy. I'm going to say 4th. This is my 4th time doing this over the last 24 hours. But we'll notice how critical these naming things are right here. So I'm going to deploy that. That'll work. And it's going to give us back an address. So go to our actions right here. Pending, 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 and then it will succeed. And we can click on it to see our address. So this is the first thing that we need right here, the address. Now we're going to go ahead and deploy the proxy. And we're going to teach the proxy about address 1. So let's go ahead and deploy the proxy. And similarly, we're going to point to the namespace. We're going to point to the KMS key. And now it's asking for a couple things. It needs the logic and the data parameter. So the data parameter is actually the hex encoded initialize function inside of your target contract. That's a requirement with this pattern right here. So logic is easy. Logic is just this. But for the initialize function, we need to essentially take this code right here, right? We need to take this function and we need to turn it into, hexadecimal representation. The docs have done that for us, so we don't actually have to do any heavy lifting. But you could do this locally with a little Web3 client. I think there's plenty of sites out there that'll do it for you as well. So why is this necessary? Because again, the proxy smart contract has to call this function, and we're speaking opcodes. We're speaking EVM at this point right here. So it needs to know kind of the low-level representation of that function. So we're going to say deploy proxy 4th right here. I'll deploy that guy. I'm pretty sure I'm going in the right order. I may have to cheat and use the docs here a little bit. Okay, so those guys are good. Now I'm going to hop back to the first guy, and I'm going to go ahead and generate some open APIs, and I'm going to invoke it. So we'll go back, go to upgrades, go to V1, go to our actions, and I want this deploy action right here. So I'm going to follow it through. Oh, sorry. I want to generate the APIs, and then I can follow it through. So we're going to create an API endpoint. And now this is where we start linking. Okay, so we're never pointing at the implementation contract to store the state. We're always storing the state in the proxy contract. So your target contract knows about the proxy. Your proxy contract knows about the implementation, right? So there's a two-way street. There's a synergy, a back and forth linkage between these two. You'll notice why these names are so critical, these action names right here. I've deployed a bunch of stuff, right? I want this one, right? I want the proxy address, which is XA77. So we're going to choose that, click next. And again, I'm going to go ahead and choose some normal names. So we'll say box upgrade demo right here. And for my actions, I'm going to say box v1 API generate 4th create. So that creates the open APIs, and now we can talk to it. And if there are questions, maybe Madison or Kevin, you can just interrupt me right here. So open this up, and now we can follow it downstream into our namespace number 2, where our APIs are going to live. So again, we're in namespace 2. That's where I deployed this guy. And this is also, reflective of why naming your APIs are important, why naming your actions are important as well. So let's go ahead and call our store function right here. So I'm going to do it through the interactive Swagger. I'll skip the item potency key, and I'm going to skip all the rest of this stuff too. So we're just going to give it an integer. I'm going to give it 456 right here. So this will default to my KMS key that also deployed this smart contract. So asynchronous, we get a 202 back essentially from the server. And this is also where you would want events to be hooked in. Firefly will index all these transactions for you, but your application needs to be listening to Firefly, needs to be listening to these smart contracts as well. So that's a really critical thing. So next step that we have here is we want to deploy our second contract. So I'm going to go back to the builds, say view all. We'll go back down to upgrades, and we're going to deploy this guy now. So just click deploy, get our namespace right, This becomes a bit monotonous, but you can tell that the naming, I'll repeat it, the naming and the patterns are really critical right here. So I'm going to say box2 deploy fourth right here. So we'll deploy that. And similarly, we can see the life cycle of this. Now, what's going to happen? I need this address because this is our new world. This is the smart contract that has the function that we wanted, right? This was the new business logic that we needed out in the world inside of our Web3 application. We needed an increment function right here, which would turn 456 into 457. We're going to just query it. We're not going to actually call that function. But again, we're going to prove that this guy can get the state from this guy. So back here, let's grab the address. And now we're going to go back to contract number 1. This is super cool. So we go to number 1, and we're going to call one of the functions that's natively imported through this Open Zeppelin module right here. So we don't actually see the function that I'm going to call. It's called an upgrade function. There's an authorize for it, but the functions and kind of the rich library actually lives in this nested or imported .sol file right here. So this is v1. So we're going to go ahead and say invoke function right here. And now we have a lot of things that we need to get right. We need to make sure we get the proxy contract right, which is this right here, deploy proxy fourth, XA77. So we're going to choose that. And now we need to choose the correct wallet. And now we need to choose the correct function. This is the function call that we want to make, upgrade to, meaning we want to start talking to a different set of solidity, a different set of logic, but we still need the state to be stored in the proxy. So we see as soon as I choose that function, it says, okay, you have one argument that you owe me for this function. You owe me the new address of box v2. And again, this is where the actions become, very important. So we're going to say box v1 upgrade right here. So I'm going to invoke that. And if this succeeds, we should, if I didn't skip a step, we should be able to go ahead and generate open APIs for box v2. And we should be able to call the query or the retrieve function and ideally get back 456. So let's see if I did this right. So last thing, back to our folder, our library. I'm going to click on this guy. I'm going to generate an API endpoint. We're going to hook it to the proxy so it knows about the state. So same address, A77. Next. And again, we want to provide sort of a logical name. So say box v1 upgraded demo. And box v1 upgraded fourth. So that gives us the open APIs for this v2 guy right here. We're referring to it as upgraded. So we can click in here, follow the API, go into our interactive Swagger, and then we can find the appropriate function right here. I believe it's retrieve. And I believe, fingers crossed on a live demo, when you have 14 different steps, I think it just takes an empty body. So you should be able to call that there. Oh, that was a post function. I wanted the query function, sorry. Where's the query? There we go. So same idea. All this. And if we hooked it in, we get back 456. So again, straightforward, but I think the pattern and the linkage and understanding when and where you continuously point to the proxy smart contract, that's the idea right here. The other thing you can do, which I'm going to skip today, but the platform does support, is if you wanted to essentially just not touch your application code and your URL, but you did want this new increment function to be available, then you would do what's called an update API endpoint. So show you how that looks. We're going to skip it today. It's not overly involved, but it does take a few steps. So we'll go to our builds, go to upgrades. V1 is the guy that we care about right here. Right, that was our parent essentially that started everything. So that's the guy we're going to upgrade. It's what we started with. It's what we're going to continuously point towards. So we go to this guy and we would use this right here. We'd say update API endpoint. And the pattern becomes similar. Namespace, you show the original API surface, and then you show the new API surface that you essentially want to overwrite onto the interface. And you do a proper name and subsequently add version 3, version 4, version 5, version 6, etc. So let me pause there and make sure there's no questions in the chat. I know that's a decent bit of information and probably new to some folks. So I want to make sure. Oh, we got Bob on. That's great. Okay, I'll just keep going since Bob's on. All right, wonderful. 2 more things that we want to cover right here. I'll sort of continuously hopscotch back to the API surface, but the other really, really critical thing that I've referenced a few times is around events. Firefly gives you a ton of events. There's things that natively happen in Firefly that its brain knows about. Contract deploy was successful. Function invocation was successful or failed, right? Tons of different areas and avenues where Firefly will index it, and you can just tell Firefly what you care about. Now, what you're going to care about inevitably are contract-specific signatures. So let's go ahead and hook up something to our 721 that we deployed earlier. So that was simple storage, and this was the 721 right here. So let's click this guy. Let's go to the actions, and let's go ahead and open this up. So 2 ways you can do this. You can do this natively against the API surface, which I'll show you right here. So go ahead and open the API. And folks probably saw this, but in addition to these invoke routes, there's /listener routes as well. So you just decide which functions, i.e. which state changes you care about. Transfer is a pretty classic one on a ERC20 or 721 or 1155, right? It encapsulates mints and burns and deployments and transfers, obviously. So we'll create a listener for this. We can do this directly in the API surface if we want, where we just specify, give me the most recent stuff you have, and deliver it to me with this naming convention, this topic. Or what we can do is we can kind of take an even easier route, and we can do it directly inside of the GUI right here. So I'm gonna go back. Apologies for all the hopscotching. Going to go to the builds, going to go to ABC, I'm going to click on the 721, and I'm going to go ahead and create a listener right here. So we don't care about the proxy now. This is just a normal smart contract right here that we don't have hooked into upgradable modules, and we don't have pointing at a different contract. So I'm going to choose this. And again, I named it properly. So 65B is the guy that we're pointing at here. So I'm going to click next. And now it says, what do you care about? What's your stuff? So my listener name will be 912 demo. And my event is going to be transfer. This is also a really fascinating thing about Firefly, about the asset platform, about Kaleido. You push source into it, and you get that easy door to invoke a smart contract, but it also indexes any events and any signatures that you have coded into your Solidity. So we care about transfer. Topic's just an arbitrary string, but as you create different event classes, different listeners, different subscriptions, this is one of the mechanisms that you would use to start, automating downstream logic. So I don't know, A, B, C, D, E right here for the topic. And then we're going to just take the newest events right here. So I'll say 912 demo transfer listener. Okay, so we'll create that. This is a immediate operation. This is a local operation. Nothing really happening on chain. This is more of a Firefly specific thing. And we're going to marry this object that we get back right here with something a bit more interesting. We're going to marry it with how we want that data delivered. So we'll open this up, and I care about this right here, this listener ID. So I copy that. Actually, I'm going to have to copy something else. So we'll leave that there for now and leave that output open. And now I'm going to go into the wide world of Firefly. So I have another instance of the asset platform open here. So I'm going to go into the namespaces. We're working against namespace 2 right here. I'm going to open up the API surface. So mention this, but the API surface is logically broken out into 2 sections. This first portion here is all of your asset platform specific operations, pushing smart contracts in, deploying them, generating open APIs, hooking into different blockchains, doing cool stuff with keys, et cetera, et cetera. Once you see namespaces, you're now in the world of Firefly. And what we care about is the subscriptions route. So down here is somewhere close to the bottom. Sorry for the unnecessary scrolling. So this is the guy that we want right here. We're going to enumerate the namespace 2, and then we're going to tell the system, hey, deliver it to me on a WebSocket client against this topic, or push it to this endpoint, for example. And to add a little more context, this could be a cloud service, right? This could be think AWS. This could be an API gateway. You could have different lambdas, serverless functions behind it saying, hey, when I get an event with this topic and Nick Gaski's address, go mint him a bunch of coins, for example, or go ship him a set of Pro V1 golf balls. So I'm going to say namespace 2 right here. That's the only argument I need in this API. And then this is kind of the beast of the schema. This can be as secure and as bespoke and as customized as you want it to be. You see how verbose it gets with tags and topics and different TLS configurations, batch timeouts, et cetera. We'll go with a very vanilla one today, just to kind of make life easy and digestible for folks. So this is documented. I have a little cheat sheet that Bob gave me here. So I'm going to just use that instead of the actual public facing raw docs. So we're going to post this into the body. Okay, so it's saying, give me this thing via webhooks. Name, I think I said A, B, C, D, E. And this is kind of the most important thing. These 2 things right here, the endpoint that you want to push it to and the listener object. The listener object corresponds to that signature, that state change. And if you remember, we said transfer. So if I do a mint, I do a burn, I redeploy something, for example, I'm going to get all of that. So now we want to go back here, and I want to copy this guy, BA2. So we'll overwrite this placeholder syntax. And I'll press delete so it looks pretty. And then we just need an endpoint. So what I have is webhook.site right here. So another convenient one is request catcher. I don't think using an API gateway is really a big charge. I believe it defaults to using, I think it uses CloudWatch and an S3 bucket out of the box. So you may get hit for $1 or $2 if you go with the vanilla AWS implementation, but nothing onerously expensive there. So we're going to point it to where we want the data delivered, 852. You just confirm that, 852. Okay, super. And we just go ahead and invoke this. This is saying, just give me everything that happens, from this current point in time. We could also say, give me everything that happened since the beginning of the blockchain, for example. A bit expensive if you're going to be using a public blockchain, but every application, every use case, every multi-party workflow is different. So you have complete flexibility over when you want those events to start. So that's the event. And now what we can do is close this guy and we'll jump back into that API. So open this up, go to the API, and we'll call a safe mint. And I need an address. So let's grab an address. And again, this is very indicative and very reflective of why you will write cloud jobs and why you will automate this ultimately. So I'm using KMS. I'm using this key right here. And this is the guy that deployed it. So this is the key that will sign the transaction, but I'm just going to mint it to myself. So back to the Swagger. We're going to use this function right here, safe mint. So try it out. Again, item potency key is optional. It is a best practice, but we're not doing a bunch of operations today. So that's pretty easy to forego. And delete that, fill the comma. And again, I'm going to send it to myself. It will auto index, kind of the numbers, the sequencing of the NFT. And then, I don't know, this is just an example. This would be where your metadata actually gets stored. And this would point to your specific asset, like an IPFS hash, for example. So again, fingers crossed, I think I did all that properly. Asynchronous response, we get the 202. And as soon as that actually makes its way on chain, then our backend will get the event right here. So we can start seeing the different types of information that we can filter against. Filter against the topic, filter against the namespace, filter against, who it went to, for example, the address of the smart contract, the function that was called, et cetera, et cetera. And again, I'll just reiterate, that's how you start reacting to things that happen on chain and happen off chain. We spent a little time last demo, sort of not in depth, but lightly decomposing this notion of multi-party messaging, public and private. So if we go back to the Asset Platform API and focus again on Firefly, we'll see that there's a data route in here somewhere. So if I find data and I find messages, these are the two things we want. So data allows you to link up with an S3 bucket or a blob container, or just utilize your local Postgres database that comes with Firefly. It is your sovereign, your private database that, again, is local to your instance or delegated to a cloud service. This is where you put sensitive stuff, invoice information, patient information, other financial information, right? Anything that's sensitive but needs indelibility and is critical in your workflow. So that's how you push data, or link data rather. You can also just publish it if you want, kind of a nice convenience function of, I may not send this to anyone, but I just want to put it out on the blockchain and maybe associate some metadata with it so someone could request it from me. Now we see that there's the option to send messages against these datas, right? Against these different schemas. And we can send two different classes of messages. We can send a broadcast, or we can send a point-to-point, org-to-org, instance-to-instance private message. And that'll run via, Kaleido's Apache Kafka backbone. It'll use PKI infrastructure and, one-time symmetric key generation to do all sorts of encryption. The point I'm getting to is when you send a message, you can do three really interesting things. You can define schemas, JSON schemas that you must conform to. You can also supply tags and topics. So it becomes very logical, very elegant, very practical to differentiate between different classes and different types of messages, and then to go more granular against those and say, hey, this is a message for Bob, and it's about, the iron ore that I just purchased from you, for example. He gets it. It was an invoice information, or it was ESG, carbon certification information, sends it down to his audit department. He likes it. He pays me, for example, or he waits until in the real world, he actually gets that asset, then he pays me, right? So start thinking about a delivery versus payment flow as one of the life cycles that can support. So I think that's more or less what I wanted to cover today. Oh, one other thing, super cool. So we talked about the kind of breadth of chains that we can talk to. We were talking to Besu, hosted on Kaleido, private. What if we wanted to talk to a testnet or Ethereum mainnet or a supernet or a subnet, for example? The system will also support that. So those connections are defined inside of your blockchain module right here. And those correspond with a namespace, of course. So if we want to deploy, our 721 that we just created, ABC, this guy right here, say deploy, but now we're going to choose a different namespace. Now maybe I choose Polygon Mumbai, for example. And this is a wonderful feature right here. This is going to let you know whether you can afford that transaction or not, right? Whether you actually have enough fuel inside of your gas tank, inside of your wallet to successfully pay for a slow or a medium or a fast transaction. And you can configure that, which you may have to help me here, Bob, where the configuration is. So if we go to the connector, and no, Bob, if you're watching, maybe you can tell me where you configure the gas price and all of those things. If not, I'll find it here in a second. This was a impromptu example. Hiding in plain sight somewhere is a bunch of stuff you can do around telling the system.
Hey, Nick.
Hey.
Bob said go to the connector.
Go to the connector. Okay, that's sort of where I'm trying to start.
I know I'm unmuted. So go into Polygon Mumbai.
Okay.
And then hit the edit button there.
Yeah. Okay. Thanks, Bob. Okay. So this is where you can tell the system how you want to deal with a public network. How many blocks do I want to wait before I trust that, that transaction is, sealed safely in the canonical chain, right? Do I want to use an oracle? Do I want to query the node with the estimate gas call? Do I want to just hard code something, right? It's a test net. My wallet's loaded. I'll just overpay for all of this. Do I want to set a limit for, the gas? Do I want to, configure kind of my, in-flight parameters right here, and then auto fuel as well. So one really powerful feature that Kaleido provides that can be very attractive, not just to financial institutions, is we can custody crypto for you, right? You don't actually have to have the legal liability to have and supply crypto. This will turn into essentially a line item on your bill. So we call it a gas station, but essentially it's all you can put into the truck, all you can pump into the tank, essentially. And again, there's no markup here. This is just a pass-through cost, and you're indemnified from that liability. Thanks for that, Bob. The last approach I wanted to show was, what if we are talking to a public network, or what if we're late to the game and a multi-party workflow, and we need to create our own interface. In a multi-party or a private consortium, you're going to know about the endpoints, you're going to know about the ABI, you're going to know about those open APIs. So it's really easy for you to say, hey, just generate me open APIs. All I really need to know about is that deploy operation. Public network's a little different right here. So let's look at the other way to kind of create a build or to create a deployment. So let's go into this guy right here, create a build. And we're going to go with the last option right here. We're going to upload the ABI for an on-chain contract. So logically, it's saying, all right, give me the ABI. So this is a ERC20 contract. So I'm going to take this, very vanilla, a lot of the same functions we just saw in the 721. So I'm going to take that, chuck that in there, click next, and we'll leave that in ABC right here. I'm going to call this ERC20 demo build. And now it's going to ask me for the address, right? When I go to deploy this, it's going to say, okay, that's fine. I know about the ABI. What's the address that I need to essentially allow you to have APIs against this? So I can click on this and it's not overly interesting, right? I said it's already been deployed. So it's going to say, all right, tell us about what you want to talk to. So it's going to force you to provide an address. So that's your one responsibility. Getting the ABI is typically not a heavy lift, right? Source code's public. You can find that on block explorers, et cetera. You can even, find that through, Web3 commands as well. So we'll give it the address. And now we're going to have a new interface that we can talk to. It's going to also say, what world is this contract in? This is out there on the testnet right here. So we'll say ERC20 demo Mumbai. And again, customize these names right here. Let's say the same thing, ERC20 demo API generate. So we'll create that. And now we have our own custom interface to talk to a pre-existing public smart contract. So a similar pattern that we saw through the other workflows, but kind of that edge case scenario of how do I still get the easy buttons, but interface with a contract that's been out there for quite some time, that has a bunch of state, for example. And again, if we look at the API, this is where life gets really cool and really exciting. We can run event listeners. Oh, this was the wrong one. This was data stored. Sorry. Look, regardless, we can run event listeners, against the functions that we care about, and we can extract the entire state of that contract from, block 1 million, block 0, when it was deployed, when I started caring about it, et cetera. So that's, I guess, the 101 or the 201 life cycle of how to get source into the system, how to upgrade source, how to put custom bespoke listeners against your back end, and how to create interfaces for pre-existing contracts. So I'm going to stop there for today and see if there's anything I can help with in the chat. So question about IPFS Gateway. We'll do a NFT specific demo, probably 2 or 4 weeks from now, where we'll focus more heavily on digital assets, more heavily on the different modeling languages for NFT metadata. We'll show an example application. We'll decompose the art of the possible, I guess, in terms of all of those things. IPFS will play a core role inside of that. I think Bob answered that question as well. So I'll wait 1 or 2 more minutes, see if there's any other questions, but I believe Madison has put a few links in the chat. If you would like to talk to us about getting access to this portion of the platform, just reach out to sales@kaleido.io. If you'd like to just talk about your use case, that's perfectly fine as well. If you're looking to move fast or looking to move in 2024, that's also perfectly fine as well. We're open to any class, any type of conversation that will help accelerate your use cases and your business as well. So again, this is recorded. you should get this in roughly 24 hours. We'll share, you know, the relevant slides, although I only showed one today. We'll show some relevant links, etc. And stay tuned. We'll update the marketing communications with details on the upcoming webinar as well. So just want to end by saying thank you to everyone that attended. Hope everyone's staying safe, staying healthy. Big thanks to Bob for helping out in the chat while I was hopscotching through those different flows. And yeah, don't be shy. Reach out if there's anything we can do to help, or if you just want to talk. So that'll conclude today. Thanks again, folks.